Good morning to everyone. Today I discuss the next topic, which is parallel inverter. Previous lecture I discussed the series inverter circuit. So in this lecture I discuss the parallel inverter circuit. Which is inverter? The inverter is a circuit which convert DC to AC. Okay. So there are many types of inverter circuit: series inverter and parallel inverter. When the load is connected in series with ACR is called the series inverter, and when the load is connected across the ACR is called the parallel inverter. Okay, the circuit diagram of parallel inverter is, this is the circuit diagram. Okay, this is the load, this is the secondary winding, okay, and this is the primary winding. This is the SCR or thyristor. Okay, this is the SCR. Here the gate terminal, this is the T2, and here the gate terminal, this is the T1. Here a capacitor C is present between two SCR. The plate of the capacitor, this is the A plate of the capacitor, and this is the B plate of the capacitor. This is the capacitor plate. This is the capacitor plate, A capacitor and B capacitor. Next, this is the center trap transformer. Okay, this is the center trap transformer, and it is the inductor and a voltage source, which DC voltage source which convert to AC. Okay, this is the voltage source V and inductor, this is the L. This is the circuit diagram of parallel inverter circuit. Okay, so this is the primary winding, this is a center trap transformer, this is the primary winding, and this is the secondary winding. This is the secondary winding and this is the primary winding. The thyristor is connected. The load C and L, this is the load, and which is across the thyristor, means this is the parallel connection of thyristor, so it is called the parallel inverter. Okay, here the center trap transformer is used. First, basically this is center tapped transformer, okay, which has a primary side and secondary side. Second is capacitor C, which is used for complementary commutation. Commutation means turn off the SCR. Commutation means turn off the SCR, turn off SCR. Complementary commutation means which is on after the capacitor is used, this SCR is off, and which SCR is off, the capacitor turn on the SCR. Complementary means if this thyristor is on and this is off, the capacitor turn on this thyristor and turn off this thyristor. Okay, turn on and turn off is alternate. So it is called the complementary. On and off alternate, so it is called the complementary. Okay, so this capacitor is also used for turn on or turn off the SCR. Okay, but how the turn on and turn off is occurs? So if T1 is triggered by an gate pulse, okay, means a signal is applied to the gate of the SCR, so SCR T1 is on. If T1 is on or by applying a gate pulse, okay, capacitor C turn off the T2. Okay, if T1 is on, capacitor C turn off the T2. If T2 is on, okay, capacitor C turn off the T1, so it is called the complementary. Okay, if SCR T1 is on and firing at T2 means triggered at T2, capacitor C turn off the SCR T1, and if the SCR T2 is on and triggered at T1, capacitor C turn off the T2. There are two types of mode is available in parallel inverter. Two mode 1 and mode 2. Two types of modes are available in parallel inverter circuit. Mode 1 ki, what is mode 1? Na triggered to T1. So T1, a gate pulse is applied to the T1. Capacitor C turn off T2. This is the mode 1, when the T1 is on and capacitor C turn off the T2. When the T2 is on, capacitor C turn off the T1. So capacitor voltage, okay, A plate, this is the A plate and this is the B plate. A plate is positive and B plate is negative. A plate is positive and B plate is negative. This is the plate. A plate is positive and B plate is negative. So current flow, primary current flow through, okay, this the center trap transformer is denoted by this point, is denoted by O, okay, and this point is denoted by P and this point is denoted by Q. So primary current flow 0 means O to Q to T1 to V to L to Q. Okay, O से Q से T1. Okay, this terminal O से Q से T1 से V, this path. Okay, this is the mode 1 primary current. This is the mode 1 primary current. Okay, So secondary current, we determine the secondary current. This is the load, and for this secondary current, so this is the load, and this terminal is positive and this terminal is negative, because this terminal is positive and this terminal is negative. This is the positive terminal and this is the negative terminal. So the current goes through this negative, positive to negative. So this current is flow from positive, start positive and goes to the negative terminal. So load current, this is positive terminal, so at the secondary this is the positive terminal and this is the negative terminal. Current flow from positive to negative. So this is the load current. Okay, so output is positive, because this is the direction is positive. Okay, this is the mode 1. Next we discuss the mode 2. Mode 2 where happened? When triggered at T2. Okay, in the mode 1 triggered at T1. So capacitor C, which capacitor C? The turn off the T1. Okay, capacitor C turn off the T1. So the capacitor charge of the capacitor plate A is negative and B is positive. Capacitor plate, this is the plate. So capacitor plate A is the negative and B is the positive. This is the capacitor. Okay, which turn off the T1. Okay, so this plate, the capacitor plate is opposite. For opposite in mode 2, A is negative and B is positive. So this turn off the ACR 1. Okay, so primary current when T2 is on and T1 is off. Primary current flow when T2 is on and T1 is off. So primary current flow from O to P to T2 to V to L to O means this path. When T2 is on and T1 is off, the primary current flow this direction, O P T2, this path V L O. This is the primary current. When T1 is on, this current is flow this direction, and when T2 is on, this current is flow this direction. Okay, so we determine the secondary current. Okay, this is the primary current, and here the secondary current is obtained. So we get the secondary current, means this is the load and this is the secondary terminal. This is the load. So in this load, which terminal is positive and which terminal is negative? So this terminal is positive and this terminal is negative, because the current flow from this direction. So this is the positive, so this is the positive, so this is the positive, and current flow from positive to negative. Okay, this is the current flow from positive to negative. So this is the positive, means this positive, and this is the negative, means this negative terminal. Okay, which is, so this is the positive terminal and this is the negative terminal. Current is flow from positive to negative direction, means this direction. Okay, positive to negative direction. So output is negative. This is the parallel inverter which generate AC signal. AC signal output is positive when T1 on, T2 off, and this is the negative, which is negative. So output is positive, so means this is the positive output, and output is negative. So this is the negative output. So T1 is off and T2 is on. So is generated sine wave, means AC signal. This is the working principle of parallel inverter circuit.